Guys, here is a very important pattern that we have just seen. So here, so we know that this cell is the maximum value obtained when we only have these two items, and this item we have not chosen. So this is the cell. So we have to, so for this, once we include this item, so we have got two options, right? Either choose this item or not choose this item. If we don't choose this item, the value is 2. So we have to essentially take max of two possible values. If I choose this item or not choose an item. If I don't choose this item, so that is the first condition. Max of two values, right? So it would be, first of all, let's not choose this item. So in that case, whatever is above cell, we take that value, right? So this is the first condition when we don't choose the value. Then when we don't choose this item, we already found that this is the value 2. Now the second scenario is that when we choose this item, now we see that if we choose this item, we have got a weight of 4 kgs, right? The second scenario is that if I choose this item, right? So if I choose this item, then we have to take the value. What's the value for this? So it's like value of this item, which is 10. And we have to also like add that if for the bag of capacity 5, we already know that if it was 5 minus the weight of 4, that is 1, what was the maximum value possible with just these two items, right? So it was 2. If we have a capacity of only like 1 kg, right now we have got a bag of 5 kg, for example. Now we include this item as well, and this space has been occupied from 2, 3, 4, 5, and now we choose that the total value because we have got this extra 1 kg extra here. So 1 kg, what was the maximum value possible with these two values, right? So this is 2 already. So it means that for 4 kgs, we choose the value of 10 plus whatever was possible, maximum value possible with only 1 kg bag, which is 2. So value of this item plus whatever we have, whatever was possible whatever was possible with the index capacity 5 minus the weight of this item. Capacity minus weight of current item, and whatever the value was there, we can call it as KP value. Knapsack. Yeah, just K. Okay. So whatever value is there, we choose the maximum of these two. So we found that 2. It was the first case when we don't choose this item. It was 2, max of 2, or the max of, if we include this item, of 10. So value 10. Value of this item is 10 plus the knapsack value that we found by reducing by 5 minus 4, the weight of this item, which is this one. So this is taken from either this value or the maximum of the value of 10 plus 5 minus 1. 5 minus 4, which the weight of this is 2. This cell. So it's 12. So we see that 10 plus 2 is greater than this one. So it's the value is 12 here. Similar thing we go with here. So it's like a sliding window that we choose that 6. For the 6 kg, it would be, I have to choose this one without excluding this item. Or we take 6 minus 4, which is 2, this. So 10 plus 2, 12 is again greater than 2. So it would be 2. This would be 12. So similarly, we keep on going on like this. Similarly, it goes for the other cell formulas. Again, if we have like capacity of 11, either we don't choose this item, so it should be max of 2, or the value of this item. If we include this, the second case, if we include this item, then the value of 10 plus whatever was there after with 12. Sorry, with 11 minus 4, 1 is 7. So this cell, 10 plus 2. So we know that this is 12. 12 is the maximum number out of these two. So we choose this item. And now again for 12, now again the same formula goes, if whether 4 or 12 again, so it would be 12. Similarly, it goes for other cells as well, because we know that the maximum value is 6 here, and once we include it, it's already 12. So we'll keep on using this formula as we just reduced here by our basic intuition, and then we will fill the whole, all the cells, and the final value would be the last cell. So let's do it for this again. So if the weight is 1, so we choose whatever was there before by just choosing this item, which is this, whether max of 2, or the value of this item 1 plus the weight is 1, which is 0 here. So this cell 1 plus 0. So 1 plus 0, it would be 1. So maximum is 2. So we just copy here from 2. Similarly, we keep on filling these other cells. Now let's see for this cell. We have got the capacity of 6 kg. So it means that if we in the first scenario, if we don't choose this item, the value is 12. Or if we include this item, it means that we have to take the value of this item, which is 1, plus whatever was there with capacity of 5 kg, which is this one. So value of this 1 plus 12 is 13. So maximum value would be 13. So here we have seen the new value. So similarly, we keep on. So the formula again, it's if I remove this item and just choose these 3 items, the value that we got is 12. And the second case, if we choose this item, we add the value of it. This is 1 plus 6 minus 1 is 5. And this is the value, maximum value we got before. So 1 plus 12 is 13. And this is how we got this. The max is 13. So we have just put 13 here. Now let's go with the last item. I already pre-filled all those values as the formula as we discussed here. Now for this cell, the capacity is 3 kg. We get the maximum value of 2 here. If we don't include this item, the 5th item, or it would be the value of this 5th item plus whatever we have weight. 3 minus 2 is 1. So this cell, so 2 plus 2, 4. That's why it should be 4 here. Now let's go for this cell of capacity of 8 kg. We know that excluding this item is 13. And now if I include this item, the value of this 2 plus 8 minus weight of 5 is 2, that is 6. 13 plus 2 is 15. So 13. So it should be, the answer would be 15 here for this capacity of 8 kg. So keep on, again, do the same formula for 9. It would be, again, 13. If we don't choose this item, this is the cell that we have to check, which is 13. And again, doing the same formula as this one, it would be 9 minus 2 is 7, 13. Plus value of this is 2, is 15. So it would be 15. Now for the last cell, which is our answer. So again, let's check this. If we choose this, if we not choose this item, the first condition, then it would be the value is 13. And if we include this item, it would be value of it, that is 2 plus 15 minus 2 is 13. And this is 13 cell, 13 here. So this cell is 13 and 15 is, so the final answer is 15. Okay. And it matches with whatever we have calculated before. So guys, this, I mean, for any dynamic problem, as we discussed, that we first of all break down the whole problem into base cases. We started with capacity 0 to 15, and we check whether by adding one by one each item. The base condition starting with empty, and then we kept on adding the items one by one. Started with first item first, and then take 2 items, 3 items, and we calculate the corresponding maximum values possible. And now we are in the DP. In any dynamic programming bottom-up approach, we try to reuse the previous problem, previous subproblem that we have already calculated, and then we derive the formula here by just observing the pattern that is being followed. If we not choose this item or we choose this item, we came up with this algorithm. So again, I mean, this will just give me the maximum value possible. And if we want to choose that, what are the items which were chosen, right? It's a 0-1 knapsack problem. So again, just based on this algorithm again, we can see that if this value, if it is same as the above cell, right, it means that we are not choosing this item, because this is our first condition. If we don't choose this item, whatever is in the cell above, we take that value. So if this value is same as this one above cell, it means that we have not chosen that item. So let's see that in this example, and if we choose this item, it means that it has been taken from some it has been included. So these are, so here, I mean, let's see. So 15 is not same as 13, so it means that it was taken from, so this item was chosen. So I will mark it here. Now 15, now let's go back to 15 minus the weight of this is 2. So this is the another cell, because this number came from this cell. So 13 is not same as 12. It means that this item was also included. So I will mark it as yellow as well. So just let me to track it. Now 13. Now we chose, if you go back to weight of 1, which is this item. Okay. So 12 is not same as 4 again. So it means that this item was also chosen. Now let's go back with the weight. So if I reduce 12 minus weight of this, so this 12 minus 8 is this one. So it means that we are at this cell. Now 2 is not same as 0. It means that this item was also chosen. And we go back with weight. From 8 minus 1 is 7. So we go here. Now we see that 0 is same as 0, which means that it was just copied from the above cell. So it means that this item was not included. And we only had this empty. Empty means nothing. So these are the 4 items that we have chosen to get the maximum value of 15. And this is same as what we discussed before here as well, that we for this problem, we don't need to include this item and include all the other items, and it will give me the maximum value of 15. So guys, this was all the dynamic programming approach. In the next video, we'll just use the same algorithm or the formula and solve this problem in Java and submit it in Hacker Earth and see whether it passes or not. So see you in the next video.